Hello, so we are going to look at this parallel circuit example problem, and we're going to calculate everything we could possibly calculate to go into the VIRP chart for this circuit. So I would suggest, in fact, if you're looking at this for the first time, you pause the video and copy the circuit over and see how much of these calculations you can do on your own, and then if you get stuck, you can come back and look at how they are done, presuming that they're done correctly in this video. Okay, here we go. So we have three resistors in parallel, R1, R2, and R3. There are also a couple of meters thrown on here, an ammeter and a voltmeter. And we're going to fill in the VIRP chart, and we're going to calculate everything we can possibly calculate. So let's start by completing the VIRP chart. First of all, the headings, V, I, R, P, hence the term VIRP chart. And then we have a row for each resistor, resistor number 1, resistor number 2, and resistor number 3. And then an additional row for the whole friggin' circuit, where we also are going to see subscripts like EQ for equivalent, or S for source, or T for total, attributed to some of these quantities for the whole circuit. All right, so what do we know to start with? We know that the voltage, or the potential difference of the source, is 12 volts. So that goes under V, which is this column, for the whole friggin' circuit, is 12 volts. That's a given quantity. And then they also give us the three different values of resistance. R1 is 6 ohms, R2 is 8 ohms, and R3 is 4 ohms. All right. And we want to calculate everything under the sun. Well, we again follow the rule with VIRP charts, which is that you can only put numbers into an equation that come from the same row or the same column. And at the outset here, the only thing we have that has more than one number in it is the resistance column. So the only thing we can calculate right off the bat is the equivalent resistance that's going to go in right there. And we do that by looking at the parallel circuit formulas on your reference table. And the equivalent resistance formula looks like this: 1 over Req equals 1 over R1 plus 1 over R2 plus 1 over R3. We write three terms because there are three resistors. This is a formula we have to be careful with, so I'm going to walk through this a little bit slowly. The first thing I'm going to do is, I don't have to see foo because I'm looking for Req. I'm going to allow myself to leave this left-hand term as 1 over Req. Even though in the end we're going to be solving for Req, so I have to be careful with that. And I'm just going to solve right now for 1 over Req. And I will plug in the values that I have. 1 over R1, I have to go back and look and see what these are. There's 6 ohms plus 1 over 8 ohms plus 1 over 4 ohms. All right. And we're adding fractions here, so as I said, I just have to be a little bit careful. I'm going to pause this for a second. Okay, so I'm going to do this calculation, and again, I have to be a little careful with this because of all the reciprocals. So, as I said, I'm going to do this kind of on the slow side. I'm going to, there's a number of ways of approaching this. You can do least common denominator. I'm going to just turn all these terms into a decimal. And so I've got my calculator here. The first one is 1 over 6, so I'm going to type 6 in the 1 over x button. And if I were to write all this out, and I think, again, this time I'm going to actually write these individual terms out. I've got 0.166, and I'm going to put a few of them down. And again, I have to be careful. This is not ohms. This ohms is in the bottom of the fraction. The unit for this term is actually 1 over ohm. Okay, plus. So I go plus on my calculator, plus. Now I'm going to do 1 over 8, and I press the 8 and the 1 over x button. The 1 over 8 is 0.125, and again, that has units of 1 over ohm, plus. Okay, so now I'm going to go to the calculator and hit plus. So right now, my calculator display is 0.291666666, and that is because that's those two terms that I have so far added up. But I've got one more. I've got 1/4. So I've got plus, and I hit 4 and the 1 over x button, which is 0.25. So I'm going to write this down. 0.251 over ohms. And I'm going to hit equals, because those three added up R, I got to get myself some more paper here. Okay, those three added up. Where'd it go? Is 0.541 equals 0.5417, 1 over ohm. Okay, that is not the answer yet, because that is 1 over REQ. All right. What I want is REQ. And so what I'm going to do is flip both sides, or if you want to look at this as 1 over REQ equals 0.5417 over ohms, you might want to look at this as a cross multiplication. I'm looking for REQ, so I'm going to cross multiply, and I get 0.5417 times REQ equals 1 times ohm. So REQ is 1 over 0.5417 ohms. That's what it comes down to. So on my calculator now, I actually have this 0.54166666, etc. on my calculator display. I want to, my answer is, I want to find, to get REQ, I need to do 1 over that number. So I've got it on my display. I'm just going to hit the 1 over X button. Boom. There's my answer. The actual final resistance, I get REQ is equal to 1.85, I'm going to round it off to 1.85 ohms. Okie doke. So again, in summary, to do this 1 over R stuff, I put it in my circle here. I plugged in, and by the way, I've got in green here the stuff that I have to see, that I have to have someone see to grade this. I've got the first line is the equation, the second line is the substitute in with numbers. This line right here is number 2 in my 3-line min. And I subbed in the values, 6 ohms, 8 ohms, 4 ohms. And again, I did not bother finding a least common denominator because for some of these problems it's going to be a pain in the butt. I went ahead and I lost something that I wrote. This is 1 over ohm plus. I got each term I expressed as a decimal. You might find it handy to actually write those down separately. I added them up, and then I did 1 over that to get my final answer. And so this is the third line of my 3-line min. REQ is 1.85 ohms. Okie dokie. That is the equivalent resistance, 1.85 ohms. Going way back up here, 1.85 ohms is the total resistance of the circuit. All right, now I can go to town and calculate all the rest of the stuff that goes into the VIRP chart. I'm actually going to take a second and get rid of this because I'm going to I want to keep this VIRP chart accessible. Don't need the arrow there. Don't need this stuff. Okay. So let's finish doing these calculations. The next thing I can do is for the whole friggin' circuit, I can find the current and I can find power. Okay. I'll do the current first. I equals V over R because I've got potential difference and I have resistance. And again, I picked the 2 numbers out of the same row, and this is the row for the whole friggin' circuit. So I've got 12 volts divided by 1.85 ohms. And Mr. Calculator, I've got, clear that bad boy, 12 divided by 1.85, and that gives me 6.5, I'm going to round that to 6.5 amperes. That goes in here, 6.5 amperes. The power of the whole circuit is V times I, and that is 12 volts times 6.5 amps, and that is, on my calculator, clear, 12 times 6.5 equals 78 watts. 78 watts goes in here for the power of the whole circuit. Okay, now how do I fill in the individual, the amounts for the individual resistors? I take advantage of the fact that in a parallel circuit, all the V's are the same. So again, make sure you're looking at the parallel circuit formulas on the reference table, and it says that V1 is equal to V2, is equal to V3, is equal to the V for the whole friggin' thing. Every resistor gets 12 volts, which means now calculating individual currents and individual powers is as easy as using these same two equations again, and I'm going to be lazy, and I'm going to simply erase the values that I had before for the resistance and for the current. And let's see, I'll probably just do one of these and let you do the rest on your own, because you don't have to watch me do the three that are the same. The first one is 12 volts over 6 ohms. 12 volts over 6 ohms is 2 amps. I get 2 amps. And the power is 12 volts times 2 amps, which is 24 watts. Okay, the second one, the current's going to be 12 over 8, which is 1.5 amps. And the power is going to be 12 times 1.5, 12 volts times 1.5, which is going to be 18 watts. And the last one is going to be 12 over 4, which is 3 amps. And the power is going to be 36 watts. And I believe I am done and I am happy. Thank you very much.